Okie doke, folks. Well, here's part 3, hopefully the final part of this quick look Shaly sand log analysis with confidence. And I'm just showing you, first of all, my last slide. And I had my face covering up that little bit. That's the equation that you might have been interested in, number 7. And the first words of number 8 were estimate free water levels. And of course, the free water level is always a little bit below the contact. Yeah, so that is a very important slide, because those of you who have done a lot of this, you'll know that once you've got the idea that you're confident about a free water level or a contact, it really, you begin to feel that you really are understanding. You feel that you really are understanding what's going on, and you've finally got a grasp of what this well is giving you. Now, of course, in places that I've worked in Southeast Asia, there are literally tens of contacts in one well. If you're lucky enough to be working in the North Sea or somewhere simple like that, you may only have 1 or 2 contacts in a well, but in these stacked shaly sands, you can have tens, or even occasionally, I've never actually had hundreds, but you can have hundreds of contacts in one well. So, and that can be an extremely time-consuming thing. Okay, next slide is going to be that what we've talked about. That was where we get some kind of an idea of the irreducibles from this chart K4 and from our marvelous NMR bound fluid log, which of course it's lovely to have this log in a low resistivity, low contrast reservoir, because of course it's not dependent upon resistivity at all, conductivity at all, is it? It's just that's why I like it, because it's getting away from this terrible obsession with conductivity that we have, and we're getting something very useful out of it, which is not the actual SW. To remember, it doesn't log the actual SW. I mean, if you log it in a certain mode and you do all these fancy things, you can get the SW from diffusion and so forth. But the way that I'm talking about it here, the quick look, the simple method, is just to say, well, because it does give you the band fluid volume, the theoretical band fluid volume in that rock, then if it was in a column, that rock would have all of that band fluid would be the only water left, and all the other fluid, the loose fluid as I call it, would of course be hydrocarbon filled. Okay, next slide is quick look permeability offsets, vshale, porosity, and SW. Now, what you may be thinking is, but we don't have cores, so we don't know permeability. Well, I mean, I have talked about it quite a bit already, that we do, but we do know vshale, porosity, and quick look SW. So permeability equations using vshale, porosity, and SW are estimated from the offset wells, where we do know these answers, right? And preloaded and K-log water zone, or below below SWI, and K-log I, which is at irreducible, calculated from these quick look results on the fly during this quick look. Offset MLR permeability is quick and useful. So we're dealing with offset wells where it's all been done, all this work's been done, and we've got some confidence in that work. We may have even done it ourselves, which may give you confidence, or it may not. But anyway, this is a very simple way. These two simple equations. You've got K-log water. The blue one is obviously a function not of SW, but just a function of a coefficient times vshale's relationship with permeability, plus a coefficient times porosity's relationship with permeability, plus a constant. That's the general format of a multiple linear regression equation. So that's the blue one, is for water and uncertain zones, and then there's the nice red one, which is more accurate usually, and more interesting, because it's being driven in part, at least, by this K as a function of SW, which of course becomes a very powerful input to relationship with permeability. Once you've got up into the column, there is a very strong relationship, as you all should know by now, between permeability of that rock, if it's a clastic that is, and saturation. Even if it's a carbonate, although carbonates are always confused by this extremely variable pore geometry, so things are not quite as simple as they are in tertiary clastics. Anyway, what am I talking about? So K Timur coats, which I always call KTC, KTC, that's roughly an equation for it, and it's very similar in form to the one that we saw earlier on, isn't it? This one. Where's it gone? It's very similar in form to that. It is basically the same animal as that chart there. Just that the coefficients are different. They're not 700. That's 70,000. They're 700,000. They're 10,000. But it's the same thing, really, the same kind of relationship we're talking about. Bound fluid volume, bound fluid volume BVF from NMR, and then, sorry, let's get rid of me. Bound fluid volume from NMR, and then porosity times SWI. Quick look, vshale, bound fluid volume vshale. So there we've got. Permeability is linking everything together, you see. You've got your prediction of permeability and you've got your predictions of saturation from this, and everything at this stage, when you've got to the end of the evaluation, these things should be, consistent with each other. That's really the point. Quick look permeability offsets from, so you've got your permeability and you compare what the implication of your evaluated saturation is with the related permeability, compare that with the offset wells and see if it's consistent. Okay, what's next? Next we have quick look offsets or rock types database permeability. K estimates enable irreducible SW. So if you've got a database, like I've got this thing I call PetroDB, which I use extensively during this kind of work, you've got sort of generic relationships for all these things. So offset or rock type databases, mine is a rock type database, permeability K estimates enable your prediction of irreducible water saturation, of course, because that is simply a function of permeability and porosity, and also of course therefore bulk volume water irreducible. This K4 means this from this chart. K4. Whenever I have K4 in a parameter, it's come from that relationship that on the other slide. Okay, so we've got SWI. K4 is the red. The red dots, that's core data. SWMV is my quick look Archie. Remember I told you about the way that we make M move around as a function of shaleness and porosity, and that's what I call SW variable M, SWMV, that's that dotted line. And this is the bulk volume water, the blue one, in the rock. This is my normal plots of the pore space, so you've got 0 and then you've got 40% and then that's the total porosity, that line there. And this grey is the bound fluid, which is the same as irreducible fluid. And this yellow is the loose fluid that can be replaced by hydrocarbons or loose water if it's below a contact. Right. And also the application of generic rock type saturation height equations, SW height MLR. So this is permeability. This is the permeability track. Oil-based mud dielectric bulk volume water not shown. Of course, I don't know if you know about the dielectric, but it will give you basically a bulk volume of water near the well bore, which may also be of help to you. Does your quick look make sense with permeability? That's really what these sort of off, sort of skew with things. They're always trying to sort of give you a kind of overall kind of, message, as it were, for the slide. Does your quick look make sense with permeability, is really what we're trying to do here. And then of course this KTC is a prediction of permeability from the bound fluid volume from the Two-Mill-Coates equation. Okay, that's enough of that. What comes next? Quick look permeability from hydrocarbon pore volume and iteration. Now chart K4 shows that hydrocarbon pore volume, which is this thing here, right? Let's get my face back in here. There we go, in case you want to see me waving my arms around, right? Chart K4 shows hydrocarbon pore volume is equal to porosity times 1 minus SWI. That's because chart K4 is about SWI, irreducible, not just SW. Has a constant value for a given permeability, even if porosity or SWI vary. This is one of these strange things that I don't know why this is not more famous. I mean, this little chart here is very simple and very, very useful, and I don't know why it's not more widely talked about. There is a relationship from that chart which is usefully accurate in many, many wells. There is a relationship between hydrocarbon pore volume and permeability, and that is the relationship, that curve. And I, being a petrophysicist, have fitted an equation to it, which is that equation, roughly 1080,000 times hydrocarbon pore volume in decimals, raised to the power 4.85, will give you an approximation, and it's only an approximation for permeability, right? Useful? I think so. KHPV is more stable across different rock types and provides the best estimate of permeability above a contact, better than generic poroperm transforms. Now, often people say to me, well, Mark, what if the rock type changes? Well, that's the nice thing about it. It seems to sort of self-compensate. If you predict permeability from porosity, you better worry about the rock type because it's going to be different if you swap rock types. But if you use hydrocarbon pore volume, it seems to be more kind of one gets bigger and one gets smaller. They seem to compensate, and you get a much more stable relationship across rock type boundaries. In my course, I've got a slide that shows that. If you, in the IPRC course that is, if your quick look porosity times SWI matches bound fluid volume estimates, we can relax. Job done. Okay, iteration. If not, iterate your least certain input. That's always the way we do it, isn't it? It's pretty obvious, really, not really clever. Iterate your least certain input, the one you're worried about, the one you thought, oh, well, I wasn't quite sure about that one. Go back to that one and vary that one and see if you can vary it to within reasonable limits and see if you can get them to match up. Okay, your quick look porosity times SWI matches your bound fluid volume. If not, iterate your... okay, NMR bound fluid volume or oil-based dielectric bulk volume water, number one. Number two, chart K4's porosity SWI implied by your estimate of K, or preloaded generic porosity times SWI. So what I'm doing is here, I'm reminding you that there are ways that you can check your evaluated hydrocarbon pore volume, right, by these methods here, 1, 2, 3, 1, 2, and 3. This full circle check becomes possible after permeability and free water level have been estimated. Chart K4 provides the approximate quantitative link between porosity SWI and K, making it far easier to arrive at a reasonable set of answers. With tertiary Shaly sands, these are usefully close to later full-scale core saturation height modeling. So yeah, there are going to be plenty of people who are going to say to you, well, you're using a generic chart. Yes, I am, but it's still pretty good. I mean, it's still usefully accurate, better than just not doing it. I mean, don't forget that Schlumberger's M equals 2, N equals 2 is a a worse fit than that. And yet we use that all the time. RW, BQV, and N are usual candidates for iteration. That means that I'm saying to you that the ones that are maybe the ones that you want to worry about are going to be these ones, right? RW, BQV, and N. So maybe those are the ones you want to fiddle around with to get the matches in this iteration process here. Right, iteration is easier if all equations are trapped in a preloaded run file, which can be easily edited and rerun, or if drag and drop interactive software is available with concatenated modules. Canned modules do bad things like truncating SW equals 0 to 1. Now, so what I'm trying to say here is that, I mean, if you are interested in petrophysics, you'll find that you really have to write your own batch file. You've got to write your own command file. You'll find that you can't rely on these canned modules all the time, because you'll find that they're just not good enough. You know, you want to do something a little bit differently to the way the CAN module's doing it. And the only way you can do that is to just write your own program. It's not very difficult. You know, and then if you want to change something, if you want to change some equation for M, if you say that M doesn't vary as a function of vshale like this, you can just change it from 0.325 to 0.326 in your own batch file, and then it'll work, maybe. Right? So if you're into petrophysics, I suggest that you write your own batch file and have it available to edit, you know, quickly and easily, as you can in interactive petrophysics, or in most software packages you can write batch files and edit them. Unfortunately, log analysis is not yet a push button process. Now, of course, we're getting into all this machine learning stuff, which is probably going to get it more towards a push button process, but I don't think we're there yet. Okay, so these are the charts for that. That's the relationship that I think is very useful but not known by most people. Here's just this. This is just the input for IP for my batch file, and this little chap over here is. I thought that was rather funny when I saw that picture. Fun little. I don't know if he was looking at his dad's petrophysical work or what. Anyway, okay, that's it, I think, folks. The next slide is going to be one of my lovely recap and process slides. And so if you are confused by this or anything really, bored by it, or want to do it quickly, just look through all of these things and then go back to the slide which it's talking about. So let's just quickly go through it. Quick look recap process. Preload generics. This is the preparation, right? You get everything loaded into your empty well that you've got there. Numbers, not just ideas. Geologists are good at ideas. We're supposed to have ideas, but actually put numbers on them, right? Calculate safe porosity with our density neutron, with the red lines, remember? Use stable NaClA max for RW. Okay, so far? Calculate MPV shale and apply the modified Archie. So we observe what M is as a function of porosity and V shale in a water zone or in other wells water zones, and then we do a nice little regression and we find a way of predicting M from porosity and V shale, and then we use that prediction in Archie, and we find, to our amazement, that Archie has suddenly become a Shaly sand equation, and it works quite well. If you want to be a bit cleverer, you can use the apparent QV and NMR QV for Waxman-Smiths. That was quite a complicated slide, but it's just really an improvement upon this simple one. And it's going to give you a better answer, but it's not going to be, well, I mean, it is going to be better. Yeah, I mean, you should do it if you've got the time. Calculate and compare generic SWI. Is there anything else? Can we, grab around for either in our offsets or in the well that we're drilling that can help us, maybe qualitatively? Dielectric oil-based mud, bulk volume water. Actually, that's, in my experience, that's a very good near wellbore value for SWI, in my experience. Locate contacts and free water levels. Stop, think, pick. No buttons to push here. There are no buttons to push on this process, but it is quite nice because you can just look at all your work, not for too long, and you can think. And it does pay to think here. It does pay to just stop and look and think. You'll find you'll get more out of that 15 minutes of thinking and questioning yourself than you will just pressing buttons and doing the next thing. Because that's it's really all about contacts, right? Calculate generic Ks, K-log at SWI, K-log water. Iterate the free water levels N to match the bulk volume water, chart K4. So I'm saying that, when you're fairly happy with things, a fairly late stage thing you can do is you can play around with N a bit to make it generate, your log analysis generate saturations that you think are comparable with other estimates of saturation from chart K4 or from NMR, SWI, etc. Right? That's all I'm saying there in that one. And then we're getting a bit sophisticated down here. Identify sensitivities, usually RW and or free water levels. The things that are really kind of messing you up are probably going to be RW and free water levels, misidentified free water levels. Use extreme 10 and 90% values to clarify feasible values. So what you do is you say, well, it can't be more than this, or it can't be less than this, and then see if it still looks like hydrocarbons or water. And then, you sort of firms you up, you sort of home in on what you think it really is. Quick review with geologist to see if she can see anything wrong. Always try and involve the geologists because, it's more fun actually to work that way. And also, of course, sometimes they think of something which you haven't thought of, or sometimes they point out some glaring, silly mistake that you've made, which it would be very embarrassing to present. So it's always good to keep with the geologist. Plot out quick look SW 1.25 to 0, bulk volume, porosity, bound fluid volume, bulk volume water. Mark as quick look tentative. Yeah. So when I do my quick looks, I often do actually plot them on S 1.25 to 0 because it's sort of actually, it gives me confidence, and if I do a little bit of chit chat to the viewers, they also get a bit confident too because they see that the SW is actually going around when it's it's actually staying around 1. It's not going crazy to 1.7 or something or 1.4, which a lot of calculations do. If you untruncate them or stop them, you'll find that a lot of whenever you see an SW line going over to 1, then just hard lining down that 1, you need to be suspicious because it's supposed to be spending half its time above and below 1 if it truly is an SW100 zone, and that's if it is truly a water zone, and lots of water zones are not at SW100. Tell the operations geologist what data you really needed but didn't get. How about that one? And then after all that, time for coffee, or maybe lunch with your mates. Okay, so that's the end of that little talk I gave to FESOS in April 2020, and it is of course basically a talk about my paper, which is called How to Do Quick Look Shale Sand Log Analysis with Confidence, which was the SPWA 2020 Bangkok Regional Conference, and it may be printed in the SPWLA proper in the future. And also my course, which is IPQL, Integrated Petrophysics Quick Look Techniques, which is a training course that I have. And another important reference is the good old Coach de Manoir 74, A New Approach to Improved Log-Derived Permeability, the Log Analyst, February 1974. A lot of these papers that are, to me, really good are not actually, necessarily new. They can be quite old. Obviously there's the Archie equation that we all revere tremendously, I think a little bit too much sometimes actually. And this one is a very good one. This relationship between the three fundamentals, porosity, saturation and permeability, as expressed in this chart K4. Okay folks, well I hope you've enjoyed that. Now it's time to sit back and get a cup of coffee and relax and think about what you've just heard. Bye.